Welcome. In this video, we will explore the fundamental concepts of subnetting. Subnetting involves dividing networks into smaller subnetworks. It is a crucial skill for network administrators and anyone looking to understand how networks are structured and managed efficiently. Let's dive in. So, what exactly is subnetting? Subnetting is the process of dividing a single physical network into multiple smaller, logical networks, which are called subnets. This is done by borrowing bits from the host portion of an IP address and using them to define network addresses. Subnetting allows for a more efficient use of IP addresses. It also improves network security and management by isolating traffic within specific network segments. Why is subnetting so important? There are several key benefits. Firstly, it improves security by allowing you to isolate sensitive systems and control traffic flow between different parts of your network using access control lists. Secondly, subnetting reduces network congestion by containing broadcast traffic within smaller domains, which improves overall network performance. Thirdly, it simplifies management by letting you organize networks logically by function, department, or location, making troubleshooting easier. Lastly, it enables efficient IP address utilization by allowing you to allocate address space based on actual needs. Before we delve deeper into subnetting, let's review some IP addressing basics. An IPv4 address is a 32-bit number, which is divided into 4 8-bit octets. Each octet is represented in decimal form, with the octets separated by periods. For example, 192.168.10. Now let's look at the binary representation. We have octet 11100000, octet 210101000, octet 3000000001, octet 4000001010. CIDR notation is also important. CIDR stands for classless interdomain routing. It specifies the network portion of an IP address using a suffix that indicates the number of network bits. For example, 192.168.1.0/24. The /24 means that the first 24 bits, or 3 octets, represent the network portion, and the remaining 8 bits identify hosts within that network. Let's take a closer look at how an IP address is structured into network and host portions. Consider the IP address 192.168.1.0/24. Here, the /24 indicates that the first 24 bits are for the network, while the remaining 8 bits are for the host. Visually, the first 3 octets are labeled in blue, representing the network portion, and the last octet is labeled in green, representing the host portion. In this example, the first 24 bits identify the network, and the last 8 bits identify hosts within that network. This allows for 2 to the power of 8 minus 2, which equals 254 usable host addresses. A subnet mask is a 32-bit number that masks an IP address, dividing it into network and host portions. It consists of a sequence of ones, followed by a sequence of zeros in binary. The ones represent the network portion, and the zeros represent the host portion. For example, the subnet mask of 255.255.255.0 looks like this in binary: 111111111.111111111.0000000. This is equivalent to /24 in CIDR notation. Here's a table of common subnet masks. /24 is 255, 255, 255.0, and it has 254 hosts per subnet. /25 is 255, 255, 255.128, and it has 126 hosts per subnet. /26 is 255, 255, 255.192, and it has 62 hosts per subnet. /27 is 255, 255, 255, 224, and it has 30 hosts per subnet. /28 is 255, 255, 255, 240, and it has 14 hosts per subnet. /29 is 255, 255, 255, 248, and it has 6 hosts per subnet. The number of hosts is equal to 2 to the power of 32 minus the prefix, -2. The reason we subtract 2 is to account for the network address and the broadcast address. Let's walk through the general process of subnetting. First, determine your requirements. Identify how many subnets you need and how many hosts per subnet. For example, you might need 4 subnets with at least 60 hosts each. Second, calculate the subnet bits. Determine how many bits to borrow from the host portion to create the required number of subnets. For instance, 2 subnet bits equals 2 squared, which equals 4 subnets. Third, calculate host bits. Make sure you have enough host bits remaining to accommodate the required number of hosts per subnet. For example, 6 host bits equals 2 to the power of 6 minus 2, which equals 62 hosts. That would be sufficient for 60 hosts. Finally, determine the new subnet mask based on the number of network and subnet bits. For example, if the original mask was /24, which is 255.255.255.0, the new mask could be /26, which is 255.255.255.192. Let's go through a practical example. Imagine you have a network 192.168.0/24, and you need to create 4 subnets with approximately the same number of hosts. To create 4 subnets, we need 2 subnet bits because 2 squared is 4. So we'll borrow 2 bits from the host portion. Now let's calculate the new subnet mask. The original mask was /24, which is 255, 255, 255.0. The new mask is /26, which is 255, 255, 255.192. With a /26 mask, each subnet has a range of 64 addresses, because 2 to the power of 6 is 64. Here is a subnet table. Subnet 1 has a network address of 192.168.10.0. The first usable address is 192.168.1. The last usable address is 192.168.62. The broadcast address is 192.168.63. Subnet 2 has a network address of 192.168.64. The first usable address is 192.168.65. The last usable address is 192.168.126. The broadcast address is 192.168.127. Subnet 3 has a network address of 192.168.128. The first usable address is 192.168.129. The last usable address is 192.168.190. The broadcast address is 192.168.191. Subnet 4 has a network address of 192.168.192. The first usable address is 192.168.193. The last usable address is 192.168.254. The broadcast address is 192.168.255. Let's discuss variable length subnet masking, also known as VLSM. VLSM allows networks to be divided into subnets of different sizes, optimizing IP address allocation based on the actual needs of each subnet. Unlike traditional subnetting, where all subnets have the same size, VLSM creates subnets with different prefix lengths. This has several benefits. It leads to efficient use of IP address space. It enables customized subnet sizes based on specific requirements. It reduces address waste, and it better aligns with the organization's needs. For example, consider a network 192.168.20.0/24. Subnet A needs 100 hosts, Subnet B needs 50 hosts, Subnet C needs 20 hosts, and Subnet D needs 5 hosts. In this case, Subnet A would use a /25 prefix, which allows for 126 hosts, and the network address would be 192.168.20.0. Subnet B would use a /26 prefix, which allows for 62 hosts, and the network address would be 192.168.128. Subnet C would use a /27 prefix, which allows for 30 hosts, and the network address would be 192.168.192. Finally, Subnet D would use a /29 prefix, which allows for 6 hosts, and the network address would be 192.168.224. As you can see, each subnet has a different mask length based on its specific host requirements, which optimizes address usage. Let's explore some best practices for subnetting. First, document your subnet plan. You should maintain detailed documentation of your subnet scheme, including network addresses, masks, and the purpose of each subnet. This is crucial for troubleshooting and for future network expansion. Second, plan for growth. Allocate more IP addresses than currently needed to accommodate future growth. You should consider using VLSM to optimize address space while still allowing room for expansion in each subnet. Third, logical grouping is important. Group devices with similar functions or security requirements into the same subnet. This simplifies security policy implementation and network management. Finally, you must consider security. Use subnetting to create security zones and implement access control between subnets. Isolate sensitive systems in their own subnets with appropriate security controls. Here are some further learning resources. You can find subnet calculators, network simulation tools, IP planning software, and network documentation tools online. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.